This is one of the theorems from 1 a day 19. So this is saying that if T is a map from V to W, if this is a linear transformation, then T is 1 to 1 if the null space of A, the kernel of A, is equal to the zero vector identically. Okay. So this is a if and only if statements. We have to prove it both directions. All right. So for the proof, we'll start by going this direction. Okay. So um, we'll first start with assume that the transformation T is 1 to 1. So assume T is 1 to 1. And we want to show then that the kernel of this transformation is identically equal to the span of the zero vector. Okay, so that's what we're trying to show. Okay. All right. So to do that, so if T is 1 to 1, then the transformation of a vector x, or u, or whatever you call it, equal to 0 can only have one solution. That's by the definition of being 1 to 1, which is namely okay. So in other words, the kernel of T is identically equal to okay. So that direction is pretty straightforward. If it is 1 to 1, it requires that the transformation of the vector to the zero vector has to equal the zero value. Okay. All right. So now let's go backwards, and we'll assume that the kernel of T is identically equal to the zero vector. In other words, the null space of A is this. And to show that it is 1 to 1, we're going to assume, suppose that T of U equals T of V. Okay, so we're going to assume that that is true. Okay, then if that's true, then we know that T of U minus T of V equals 0. Okay, so the difference is equal to 0. And then by the linearity of T being a linear transformation, we know that this is equal to T of U minus V, which is equal to 0. Okay. So U minus V is in the kernel of U minus V is in the kernel of A. Okay. Not of A, sorry, of T. And so hence U minus V is equal to 0. Okay, which implies then that U must be equal to V. Okay. Which of course implies then that T is 1 to 1. Okay. All right. So two pretty straightforward proofs, really just relying on the definition of what it means to be 1 to 1 and what it means to be in the null space. Okay, so I hope that was helpful. And I guess the really important thing to note here too is that if T is 1 to 1, then T inverse exists. Okay, so that's a condition actually for T inverse to exist. Cool. All right, I think that was really cool. It's a fun little proof. So I hope that was helpful, and I'll see you in the next video.